In this video, I'm going to show you how to organize your data into data tables. So let's say, for example, that, you were working with voltaic cells and you were varying the concentration of copper 2 sulfate in 1/2 cell, and you were measuring the effect that that had on voltage. So our independent variable, the variable that we as experimenters are manipulating, is the concentration of copper sulfate. And the dependent variable, the variable that is changing due to our manipulation of the independent variable, is voltage. So the first thing that we have to do is make sure that our independent variable, which will go on our x-axis, is on the left-hand side, and our dependent variable, which is voltage, should show up on the right-hand side, because this will appear on our y-axis, just like x-y tables in math. The first thing I'd like to check is to see that our columns are labeled appropriately. So that should include what those values are. In this case, this is concentration of copper sulfate, but also it should include units. So in this case, this is probably measured in moles per liter. Your voltage should also include units, probably measured in volts. But another thing that you should probably include there is the uncertainty of the measurement. And you get that by looking at the measurement tool that you used. So let's just say, for example, that for this particular voltmeter, the uncertainty was 0.01 volts. All right, and just as an aesthetic property, it's nice to merge those three columns together to represent that all of these values are values for voltage. The next thing that you want to do is be consistent in the decimal places that you're using or showing in your data table. So notice that this reports voltage to 1/10 of a volt, and this one reports voltage readings to 1/100th of a volt. Now, if our uncertainty is plus or minus 0.01 volts, it's likely that we should probably report our voltage readings to the 100th place. So if you select all of that, you can just play with these buttons here to get the appropriate number of decimal places. So the next thing you want to do is some basic data processing. First step is going to be calculating an average. We are not going to plot every single measurement on a graph. We would like to have this represent one data point. This is the next data point, so on and so forth. So since these three values are trials for one value of the independent variable, these three are going to be averaged. To do that in Excel, type in the equal sign, type in average. You can choose to continue typing that or simply click, and then select the values that you would like to include in the average and press enter. You can then copy that formula down for all your other data points. Make sure that your values for the average reflect the same number of decimal places as all your other measurements. We can label this average voltage plus or minus 0.01 volts. An alternative way to do this, instead of labeling that average voltage and repeating the uncertainty in the unit, is if I just copy this over. One other thing that you can do is just insert a row above your measurements. You can label this trial 1, trial 2, trial 3, and the next column can be labeled average, and just simply merge that together to reflect that this average has the same uncertainties in units as what is shown above. So if I repeat that process, and just for aesthetics, let's put some borders. There you have it. That's the most basic data processing that you can do with this set of data.